This picture right here, this is showing you how large of a size discrepancy there is between, this would be the oocyte, right? This would be the secondary oocyte that's ovulated into the fallopian tubes, and this is a sperm cell, okay? So you can see there's a very large size discrepancy between the oocyte and the sperm. And that's again because the oocyte has to contain all of the cytoplasm, all of the organelles, all of the stuff that's going to make this fertilized zygote capable of rapidly dividing once fertilization takes place. So here is a lower magnification image of the ovary, and you can see, so this would be out near the cortex. You can even see an apical space out here. So this would be out towards the cortex, and this is where you see all of the developing follicles in their many stages. And so primordial follicles, these are the least mature, and these look, to me, they look like little eggs in a basket. They are closer to the periphery of the ovary, so you can see they're clustered very close to the periphery of the ovary. They're very small. They're pretty much just an oocyte with maybe a single layer of flattened follicular cells around them, right? So here's another image. These are primordial follicles. This would be our oocyte, and you can see it looks almost a simple squamous, but a single layer of flattened follicular cells surrounding them. These are primordial follicles. Now, upon release of FSH and LH, primarily FSH, the follicles, right, when I use the term follicle, I refer to the follicular cells that surround the oocyte and the oocyte itself, okay? So once these are stimulated to start to mature, they'll develop into a primary follicle. And here's our oocyte, and now you can see that the follicular cells surrounding the oocyte, they're almost somewhat cuboidal. This entire structure is a primary follicle. Now this is also a primary follicle, but it's just a later stage primary follicle. So here's our oocyte, okay? Now this thick layer of pink stuff directly adhered to the oocyte, this is the zona pellucida. This structure is important because the zona pellucida stays with the oocyte upon ovulation, and so the sperm cells have to be able to hydrolyze and break through that zona pellucida to actually penetrate the oocyte itself. So that's where the acrosome comes in. The acrosome that contains those hydrolytic enzymes have to bore through this zona pellucida that stays adhered to the oocyte even upon ovulation. Now there are multiple layers of follicular cells, but this is still primary because we don't see an antrum yet. Okay, so this entire structure would be a primary follicle of the ovary. Now this is a secondary follicle. This entire structure right here, this entire thing is a secondary follicle. Here's the oocyte, here's the zona pellucida around it. These are all follicular cells, which they have specific names, but we're not going to go into all of the specific names. But these are all follicular cells, but we see this developing antrum right here. And the follicular cells, upon their many functions, they also secrete this fluid and form an antrum. And this builds up hydrostatic pressure, which will help rupture the follicle, releasing the oocyte at the time of ovulation. So we see a developing antrum. This is a secondary follicle. Now this is a Graafian follicle, the most mature follicle, and we know that because we see this huge continuous antrum and the oocyte with its zona pellucida, and the cells, the follicular cells that stay surrounding the oocyte and the zona pellucida, those are called the corona radiata. The corona radiata and the zona pellucida stay with the oocyte even when it's ovulated. And so the sperm cells not only have to get through the zona pellucida, but they have to get through the corona radiata as well. And that's why you have to have billions of sperm at ejaculation, because we need lots of sperm to help one get through these several layers so that one can ultimately fertilize the oocyte. Okay, so we see this oocyte pushed to the periphery in this huge continuous antrum. This entire thing is a Graafian follicle, okay? Looks like a fried egg to me. This is a Graafian follicle, the most mature. This right here, okay? this would be our, so if we go back to this image, okay, this would be our secondary oocyte. So our Graafian follicle contains our secondary oocyte that gets ovulated, and then if a sperm actually gets through the corona radiata and the zona pellucida and is capable of fertilizing the secondary oocyte, then it will undergo meiosis II, and then will split off a polar body that will degenerate, and this fertilized cell will then undergo rapid divisions to become a zygote and possible implantation into the uterus to develop into a fetus. Okay, all right. Here's another image. This shows you, so this would be the cortex of the ovary. Here, this would be the medulla, and you can see all of the blood vessels. This is where all the blood vessels, lymphatic vessels, and nerves would be. Okay, and so you can see that here's our primary follicles, right? These all would be primaries. These would all be primordials, very, very tiny. These would be primaries. Now they're later stages, right? But no antrum yet. Once we see an antrum, this is a secondary follicle. Once we see a continuous large antrum, this is a Graafian follicle. And then this is showing the Graafian follicle rupturing. So there's a huge buildup of hydrostatic pressure due to all this fluid, and it's like a little pimple popping. And then the oocyte with its zona pellucida and corona radiata get released into the fallopian tubes for possible fertilization. And all of the follicular cells that are left behind, it develops into a corpus luteum. Okay, so all the follicle cells that are left behind becomes a corpus luteum. That corpus luteum, when stimulated by luteinizing hormone, will produce and release progesterone, which helps maintain the endometrial lining of the uterus for possible implantation. Now, if there is no implantation, right, then this corpus luteum is not needed because we don't have to maintain the endometrium anymore, and it will start to degrade and become, or degenerate, and it will become a corpus albicans, okay, which is just like essentially would be scar tissue left behind.